Hello, this is Professor Broker, and this is your Chapter 14, Lecture 2, Competitive Markets, Part 2. This is for Econ 231. Let's get started. Remember our questions we want to answer for Chapter 14. What characteristics make a market competitive? Okay, hopefully you remember those three characteristics. How do competitive firms decide how much output to produce? How do competitive firms decide when to shut down? How do they decide when to exit? And then how do they determine short and long run profit? All right. We're going to get to some of those latter questions in this particular lecture. First, let's review a bit. If I give you a marginal, if I say that a competitive firm making boxes has a marginal cost equal to 4Q, and that their profit maximizing level of quantity is 10 units, okay? Then, if this is the profit maximizing level of quantity, at what price will this firm sell these particular units? Okay, now if that's all the information you have, you might think, well gosh, we don't have enough information to know the quantity. But remember, in a perfectly competitive firm, what are some of the relationships that are true? Well, at the profit maximizing level of quantity, which the problem tells you this firm is producing at, doesn't marginal cost equal marginal revenue? Okay, of course it does. And also remember that marginal revenue equals price for the competitive firm. Therefore, right, as a matter of identity right here, at this particular profit maximizing point, marginal cost equals price, and we have a function for marginal cost, right? So if we plug that 10 into this function, we know that at this level of output, the marginal cost would be 40, which would also equal our profit it would be the price at the profit maximizing level of quantity. Now that's not to say that marginal cost always equals price, but only at the profit maximizing level of quantity. And of course, marginal revenue always does equal price for the competitive firm. Okay? Now, what we need to talk about is when would it make sense for a firm to shut down, rationally, meaning shutting down temporarily, maybe for a season, the winter season, maybe a restaurant, simply, being open for lunches as opposed to dinners, or just dinner and not lunch. Versus when would it make sense for a firm to completely close up shop and go do something else with their resources? Okay, so a shutdown decision is a short-run decision, not to produce for a certain amount of time because of market conditions. So again, this would be maybe like an ice cream parlor or an ice cream vendor not selling ice cream in the middle of winter, right? Maybe they typically sell ice cream, maybe somewhere in Murray on campus. And they sell in spring, summer, and fall, but then when December, January, and February roll around, maybe they close down. Maybe they shut down temporarily because obviously the demand for ice cream wouldn't be as high in the winter. Okay, that would be a shutdown decision. What about exit though? When would it make sense? An exit decision is a long-run decision for the ice cream vendor to just pack up shop and say, you know what, I'm going to go work at Briggs & Stratton, or I'm going to go be a dentist, or I'm going to go be a corn farmer. I'm going to go do something else. I'm not going to be an ice cream vendor anymore. Okay, I'm going to exit the market. The key difference is, in the short run, that ice cream vendor would still have to pay fixed costs. So when they close down for the winter, say they have, maybe rental contracts. Maybe they rent the ice cream making equipment that they use. Okay, well they would still have to pay those costs. Because those would be fixed in the short run. So even if they decide to not make anything, they would still have those fixed payments. They would save on variable costs, but not fixed costs. Whereas in the long run, you can imagine an ice cream vendor's contracts being up, and then they, if this person left the ice cream industry, then they would have zero cost, no more fixed or variable cost to pay. They completely exit the situation. Okay? Now, when we talk about still having to pay fixed costs, okay, an important concept here is the idea of a sunk cost. A sunk cost is a cost that has already been committed and it cannot be recovered. Okay, so think about our ice cream vendor paying rent. Okay, maybe they're renting a location, and that's maybe very close to campus. They're renting a little storefront, and that's where they sell their ice cream. Well, if they're under a 1-year contract, paying $500 a month to rent this location, when it comes time for December, right? If they decide to stay open and sell ice cream, okay, then of course they're going to have a $500 rent payment. But if they decide we're not going to sell ice cream in December, we're going to go somewhere else, we're going to close up just for that month, and we're going to reopen maybe later in the spring, they still are going to have to pay the $500 rent. Okay, no matter what their decision is, they can't get that fixed cost back. So fixed cost, our fixed cost in these examples is really technically what we call a sunk cost, okay? Because it cannot be recovered. Therefore, in these evaluations, the key economic analysis, we ignore sunk costs from our decision making because it doesn't change our outcome. Because no matter what we decide, that we can't change a sunk cost, we simply ignore it from the analysis. Okay, and so that's what we're going to do with fixed costs. When we look at our shutdown decision, fixed cost is not going to be part of our decision making process because we're going to have to pay it regardless. Okay, because it's a sunk cost. Now, let's look. Now, could it be profitable for an ice cream vendor to close down for the winter months? If they do shut down temporarily, what are they losing? Well, obviously, they're losing potential customers. They would probably sell some ice cream in the winter, right? But what are they gaining if they shut down temporarily? They're still gonna have to pay fixed costs. So what are they gaining? They're not gonna have to pay any variable costs, any workers' salaries. They're not gonna have to, pay utilities and all these, maybe for materials and the ice cream and the sugar and that kind of stuff, the cones. Any of these variable costs they will save money on if they close down or shut down temporarily, right? And they'll still have to pay their fixed costs, okay, things like rent and so on. Okay, so when would it be profitable then to shut down temporarily? Okay, well, how about when the expected total revenue that they might get is less than, not your total cost, but simply less than your expected variable cost. That's going to be the key determinant when we talk about a short-run shutdown decision. Okay, because again, the cost of shutting down are lost potential revenue. The benefits, you're still going to have to pay fixed costs, but you will save variable costs. So when total revenue is less than variable costs, less than, so maybe for a given hour we have to pay some workers and utilities and so on and so forth, and say that totals up to $50. Well, if on any given hour of a day during the winter, if we don't expect, if we only expect to bring in, sell 2 ice cream cones for $2 each, and we only expect to bring in $4. $4 is a lot less than $50 variable cost. Therefore, it might make sense to shut down temporarily. Okay, now that's the general rule, but let's make it a little bit more specific. If we divide total revenue by quantity, remember total revenue is price times quantity. We divide by quantity, we're going to be left with price. Variable cost divided by quantity is going to be average variable cost. Therefore, the real rule for the competitive firm is when the price falls below average variable cost, we say that our competitive firms will make the rational decision to shut down temporarily in hopes that the price will come back up in the future, which in our ice cream example would make sense, right? We might shut down for the winter months expecting that demand will increase as spring rolls around, thus increasing the market price that people are willing to pay, therefore bringing them back into the market. Graphically, if you see here, we have our marginal cost. Remember, our marginal cost curve is our competitive firm's supply curve, but only for points above, equal to and above our average variable cost, because at this point, below this point, this section right here, remember, our firm will decide to shut down. Therefore, production would go to 0. That's why our short-run supply curve looks like this. It really doesn't start, okay, until marginal cost is above average variable cost. Which is what that says right there. The firm's short run supply curve is the portion of its marginal cost curve above average variable cost. Okay? Now, would our ice cream vendor ever decide to stay open even if they had negative profits, say during December or January? Okay, which means they're taking in less total revenue than their total cost. Okay, that would be this portion right here, right? If we're producing, right, if our price is above average variable cost, okay, so it's in this region right here, but below average total, the firm would actually be losing money. Okay, but according to our rule, they would actually still stay open. How could that be rational? Well, let's look at an example. What if our firm, let's say during the winter months, December, January, February, brings in $500 a day? Okay, their variable costs are $400 a day. Okay, so it would make sense for them to at least stay open. Their fixed costs are $250, okay, a day. Well, doing some simple math, we would quickly realize that staying open, right, Their 500 minus both of these added together, or 650, 500 minus 650 would give them a negative daily profit of $150. That doesn't seem to make sense. Well, gosh, this firm should just shut down, right? Not so fast. What would their profit be if they shut down? It would not be zero. It would actually be negative 250, because if they shut down, in this example, their total revenue would be zero, their variable cost would be zero, but they would still have to pay their rent and other fixed costs, which we've said are $250 a day. Therefore, right, they would still, their revenue would be zero, they would still have these costs of $250, therefore their profit would be negative $250. So both of these are bad scenarios for a business. Which one is the least bad? Well, staying open is the least bad in this case. That represents this portion right here on their marginal cost curve, right? That's why firms, even if they're maybe losing money in this region, they would still decide to stay open because they would be losing less money by staying open. Now, in the long run, right, a firm's rent contract can expire. Other fixed costs can expire and become variable. So when might our ice cream vendor completely close down for good? What are they losing if they exit? Well, they're losing potential revenue that they could gain from selling ice cream. But what are they gaining? They will not have to pay any costs, right, if they completely leave the market. If I stop, if our vendor stops selling ice cream and they go work at Briggs & Stratton, all right, and they don't have any more fixed costs or rent or anything like that, then they're not going to have to pay those costs anymore, right? No, there's no cost that they're still going to have to pay even if they exit in the long run, because we assume in the long run all of their contracts become variable, okay? And would a firm ever decide to stay in the market in the long run even if they were taking in less total revenue than their total cost? I guess practically speaking, it's possible for a short period of time, but in the long run, over time, right, we would theoretically no, right? A firm is not going to keep producing if they're losing money. In the real world, temporarily they might, but eventually businesses are going to run out of cash flow. They're going to run out of capital. They're not going to just stay in a money losing business indefinitely. So no, of course they would shut down. They would completely exit the market if they continued to lose money and total revenue was consistently below total costs. Okay, so now let's kind of formalize this. The cost of shutting down are lost revenue. The cost of exiting the market is lost revenue. The benefits of exiting are total cost savings, meaning you're not going to have to pay fixed cost or variable cost. Therefore, when total revenue is less than total cost, okay, over a long period of time, in the long run, we would assume that the business would exit the market. Our ice cream vendor would stop selling ice cream and go work at Briggs & Stratton or go do something else with their resources, with their time. If we divide both of these sides by quantity, in other words, total revenue divided by quantity would become price. Total cost divided by quantity would become average total cost. Therefore, when our formal exit rule for a competitive firm, when the price in the market falls below average total cost, okay, in the long run, okay, this is a long run decision, then the firm would decide to exit the market. Okay. So let's look at this graphically. So notice here we have our long run, okay, average total cost curve, okay, because all of our costs are become variable. There are no fixed costs in the long run, and our marginal cost curve is our firm's supply curve, but in the long run, only for portions of the marginal cost above average total cost. Because in the long run, when we fall below this line, this curve here, this long run average total cost, our production for our competitive firm goes to zero. Okay, so this is what our long run, our firm's long run supply curve looks like. Now, we can think about our exit decision and simply reverse it, right? When would a firm decide to enter a new market? Okay, well, I think, recently nationwide about, the last several years, even a few decades, of all the coffee places that have popped up, right? Just the little places that offer specialty coffee, like whether it's Fidalgo Bay or a Starbucks or, even a Dunkin' Donuts, and even McDonald's offering specialty coffee drinks like McCafes, right? Why would they enter that market? Well, probably because they believed consumer demand had increased for things like that. Thus, they felt like they could the price consumers were willing to pay was higher, therefore they thought they could make money, right? What are they losing in the interim? Obviously, it's going to cost money to start this new business. Even for McDonald's, it costs them money to put in the new practices in place and to order those new materials. What are they gaining, though? Obviously, they hope to make money. They hope that their additional revenue from selling additional coffee drinks, Dunkin' Donuts coming to Murray, Fidalgo Bay several years ago coming to Murray, obviously they feel like they can make money. That's why they came. If we formalize this, they felt like total revenue was going to be greater than their total costs. If we divide each side by quantity, our official rule for a competitive firm is when the price is above or greater than average total cost, we would predict that the existing firms will be making a profit that would attract other firms to the market. Okay, so I kind of want to put some of these pieces together. Okay, so basically, when price is above average total cost, existing firms in a competitive market are making positive economic profits. Positive economic profits are like a magnet and will attract other firms. Okay, new firms will enter the market, and the supply curve will shift to the right in our market. Okay, and we'll kind of formalize that more in a second graphically. Now, if price is below average total cost, so that means existing firms are losing money, and that's actually going to cause some firms to exit the market, thus restricting market supply. Okay, so profits act like a magnet and bring, like a positive negative charge. They bring firms, they attract firms to that market. Okay, think about corn farming and soybean farming, right? I mean, if price of corn, if farmers are deciding between soybeans and corn, and the price of corn skyrockets per bushel, we would anticipate existing corn farmers would be making a windfall, right? They'd be making tons of money. And that would attract other farmers who are currently making soybeans probably next season to making corn, to producing corn. Well, think about it in reverse. If the price of corn plummets, right, that would cause existing corn farmers to potentially lose money, right, everything else equal. That would mean some of them would probably switch over to growing something else, maybe like soybeans next season, in the hopes of making money instead of losing money on corn. Okay, and so that's kind of the process going on here. So let's formalize this graphically. Okay, looking at the graph, let's just start in equilibrium. Here on the left we have a competitive firm. Here on the right we have a competitive market. Okay, so let's just say this is corn. Currently, this is our long-run equilibrium, right, where marginal cost is upward sloping, price and our marginal revenue here is horizontal. The firm is going to produce here at the minimum of average total cost. Okay, and here we have market equilibrium. But let's just say that the demand for corn increases. What would that do to price? Well, the price would increase. How would that affect our firm? Well, the firm would see a higher price. That means, remember we talked about the existing quantity, or the quantity that they're currently producing at would actually not be maximizing their profits. Therefore, to maximize profits, they would increase production to this point here. Okay? When they do that, they're actually going to be producing where price is greater than average total cost, thus earning a profit. Okay, our firms will be making a profit. But remember, profits attract entry. And remember, in a competitive market, there's really no barriers to entry. If I'm growing soybeans and I want to switch over to corn, to growing corn next season, there's really nothing major that's going to stop me, right? And so I would be able to basically do that, everything else equal. And so we would anticipate if these corn farmers are making a tremendous profit, that would attract other farmers to growing corn, definitely probably by next season, if not earlier. Now, what would that do to our market, though? As firms entered the market, that would increase our supply curve. When would it become not attractive to enter the market anymore? When price dropped below the original price of P1, which means our supply curve would only shift until the price would fall back to its original price of P1. Okay, because once it gets there, that would be zero economic profits, and firms would have there would be nothing to attract additional firms. Okay, so now the increase in supply, what does that do to our competitive firm? That drives the price back down here to P1. What would a rational firm do? Well, again, if the price is back at P1, producing here would actually be producing too much, and therefore they would need to restrict output back to their original production point right here. Okay, and so we're back to basically our original equilibrium. But notice in our market we have a lot more quantity. So if the firms are now back to producing the smaller amount that they were originally producing, how could we have a larger market quantity? Well, that's because we've attracted new firms to the industry because of that profit that they had there during those middle stages that attracted new firms. So we have more firms, thus we have higher equilibrium quantity. Now this process has basically led us to a long-run horizontal supply curve for our competitive industries. Now there are some reasons that we might expect that our long-run supply curve, even in competitive industries, might be slightly upward sloping. Your book talks a little bit about that, but the main point I want to discuss is the fact that our long-run equilibrium for our competitive firm, okay, because of free entry and exit by firms, is going to be right here, where price equals marginal cost, and where marginal cost equals average total cost. Thus price equals average total cost, and that means zero economic profit for our competitive firms in the long run. In other words, as firms are making profits, other firms enter and gobble up those profits. If firms are making losses, some firms leave, erasing those losses. Therefore, we always, in the long run, will arrive where firms are earning zero economic profit. Okay? Now you might say, well, gosh, why would a firm stay in business if they're earning zero profit? Remember, I said zero economic profit. Firms could be making an accounting profit, but we would just assume in the long run that these competitive firms are not making profits over and above using their resources in their next best use. In other words, economic profit would be zero. Okay? But accounting profit could be positive. Okay? Now, our long-run equilibrium, remember that our zero economic profit condition for our our competitive firm in the long run is where price is going to equal average total cost. Okay? Now remember, price equals marginal revenue for our competitive firm at the profit maximizing level of quantity. It also equals marginal cost. Okay? And because price equals average total cost, okay, in the long run equilibrium, we know that our firm is producing at the minimum of average total cost. Again, because price equals marginal cost at the profit maximizing level of quantity for our firm, and we know that they're also producing where price equals average total cost. Thus, remember from chapter 13 that where marginal cost equals average total cost, which is where our firm is producing in the long run, remember that represented our efficient scale, our minimum of average total cost. Thus, our competitive firms are producing in the long run at the minimum of average total cost, which is a very efficient level of production. It's not maximizing, it's not generating them tons of profits, I'll grant you, but in terms of the market condition, it's a very efficient level of production. Okay, so that's an important component that an important outworking of our competitive market analysis. Okay, now let's apply that. Let's apply kind of what we just talked about to a question that you might or might not see on an assessment. Okay, for this class. Let's look at this question. If the price in this particular market, okay, notice we have an upward sloping supply, we have an average total cost curve and an average variable cost curve. If the price is currently P1, so it's right here at 6. Okay, the price is P1. In the short run, what will happen in the long run? So in the short run, right? Okay, where would the first question you need to answer is where would the firm produce? Okay, the firm would produce, boom, right there. Because remember, our price, our horizontal price here, is our marginal revenue, and the firm's going to produce quantity where marginal revenue equals marginal cost, which is right here. Okay, so they're going to be producing 3 units. Now, at that point, is the firm going to be making a profit or a loss? Well, really, before I get there, really I need to ask, is the firm going to produce or is the firm going to shut down temporarily? To answer that question, I need to see where this point is in relation to our average variable cost. Is it above it or below it? Well, boom, right now we're producing and the price is above average variable cost. Therefore, the firm will produce. The next question we need to ask is the firm making a profit or a loss? Okay. Well, to answer that question, we need to know is the current price above or below average total cost? Boom, we're above it. So this firm will produce in the short run. They will not shut down, and they're making profits. Okay. Well, think about the long run. What did we just talk about? If price is greater than average total cost and the firm is making profits, imagine this is a corn industry. Other people, other farmers that aren't currently making corn, what do they notice? They notice that corn farmers are making a lot of money. So what would that do? That would likely attract some farmers to enter the corn market. Okay, so basically what answer says that? Well, answer A says nothing would happen. That's not true. Answer B says individual firms will earn positive economic profits in the short run, which is true. which will entice other firms to enter the industry. That's true. So the answer is B. If the price is at P1 in the short run, okay, the current firms will be making a profit, which will attract other firms to the industry. And in the long run, actually, what would happen is the price would get driven down to this minimum right here. Looks like about 4.5. Okay. Next, what if the price is P2? Same question, but the price is P2. Well, at a price of P2, the firm will produce, boom, there, okay, which looks like 2 units. Okay, is it above average variable cost? It is, so they'll produce. Is it above or below average total cost? Well, it looks like it's actually equal to average total cost, which means the firm would be making 0 economic profits at a price of P2. That's not going to attract or repel any firms in the industry. So actually, this would be long run equilibrium. So nothing would actually happen, right? Because the price is consistent with 0 economic profits. So there's no incentive for firms to enter or exit the industry. Okay. Now, what if the price is P3? Okay. Well, if the price is P3, where will the firm produce? Boom, right there. Okay. Is that price above or below average variable cost? It is above it, so the firm will still produce and not shut down. Is the firm making a profit or a loss? Well, we're actually below average total cost, so we're actually making a loss. So what would happen? Some firms would leave the industry. It would repel some firms. That would then raise the price, okay, up until we get to probably P2. But I think the answer we're looking for is that we're making losses. Existing firms are making losses, and so some firms would leave the industry, which looks like answer C. Okay. And then finally, what happens at P4? Okay. Well, if the price is at P4, where will the firm produce? Boom. Okay. Are we above or below average variable cost? We're actually at a price of $2 here, P4. We're actually below average variable cost. Right? Which means, remember our shutdown rule, if the price is below average variable in the short run, the firm's actually going to shut down. Okay? So the answer there would be D. Okay? Now, what did we learn? We've learned in Chapter 4, our profit maximizing rule is where marginal cost equals marginal revenue. In a perfectly competitive firm, price equals marginal revenue. Therefore, the competitive equilibrium is price is going to equal marginal cost. Now remember, marginal cost is the extra cost of production. And remember, price is the extra value or the value to the buyer of the marginal unit, the extra value to the marginal buyer, in other words. In other words, the competitive equilibrium exactly equates the extra benefit in the market to the extra cost of production in the market. What does that do? Well, you'd have to go to Chapter 7 to learn about total surplus, but that's going to maximize our total surplus or the size of our economic pie. Therefore, competitive markets are just a beautiful thing for economists, at least, because again, it maximizes the size of that economic pie. It maximizes efficiency, and that's one of the things we can derive from this analysis. In the next chapter, we're going to see that when firms have pricing power, that it's actually going to create a deadweight loss, and it will not maximize efficiency in the market.